It's really yummy frozen custard. And we have a problem about it. Okay.
I've been there.
Excellent.
And I got the chocolate ice cream.
I get the chocolate too. Okay, so the problem is the Caltech Creamery at the Star has the best waffle cones that can be filled with their yummy frozen custard. But on a warm Texas summer day, some of the custard melts down the side of the cone. If the entire cone is covered in melted ice cream, but there's still some ice cream on top of the cone, how much is on the outside of the entire dessert? Which, by the way, if it's on the outside of something, it's surface area, right? Because surface area is on the outside. So essentially, we're finding the total exposed surface area of this whole thing. So, what shapes do you see in this picture?
A cone.
A cone and
Semicircle.
hemisphere.
Yes.
Half a sphere or a semisphere or half a sphere. Yeah, however you want to call it. So, we're going to do them separately and then combine them. So we are going to be adding the half sphere surface area. And do we want the total surface area of the cone or the lateral surface area of the cone?
Total, because you're trying to find the drip down.
Is this part on the outside? Is the circle base on the outside of our ice cream?
Yes. Oh wait, no.
Are you sure? There's ice cream on top of it, right?
No, circle base is inside.
Right, so the circle base is hidden under the ice cream, so it's not on the outside, which means it's not going to be included in our total exposed surface area, right? So surface area with no base is just lateral. So we're just going to find the lateral surface area of the cone. Because the lateral part is just going to be this part I'm coloring in orange. So let's do the sphere first, and then we'll do the lateral cone, and then we'll combine. So the formula for a sphere is 4 pi r squared. And we only want half of it, so I'm just going to divide that by 2 because we only want half of a sphere. So what's the radius of the sphere? 7. So 4 pi r, 4 pi 7 squared divided by 2. So I'm going to figure out what that is. So 4 times pi times 7 squared.
So you have to do the 4 pi 7 squared first before you divide it. Okay.
So I got 307.9
Yeah.
for the half sphere. Okay, plus the lateral surface area of the cone. So find that on your formula chart. What's that formula?
Surface
Two.
equals pi squared, or pi times radius times.
Slant height, yep. So for our lateral surface of the cone, it's equal to pi times the radius times the slant height. So pi times 7 times 15. So we'll figure out what that is. Okay, I got 329.9. And now we'll just add. So 329.9 plus 307.9. So 637.8. Let's see. Units. Ooh, inches. We have inches. Inches squared. Okay, so sometimes you'll have to find two separate surface areas and add them together. And you always just kind of need to be thinking about which shapes that I'm seeing are included versus not included. Like here we decided we didn't want to include the base of the cone. So those are the things to think about, what you want to include versus not include. Let's do another one. Okay, instead of reading it all to you, I'll just explain it to you. So essentially, we're looking at a pipe. So the pipe is like a cylinder that has had a cylinder-shaped hole drilled through it. We all know what pipes look like, yeah? So they're going to be painting the pipe red, just the outside of it. So essentially like the outside of the pipe and then like the top and the bottom. They're going to be painting it red. And we want to figure out how much paint they'll need to coat the outside. So again, if you're trying to like do something to the outside of your shape, that's surface area. So if we're thinking about it here, we don't just need the total surface area of a cylinder. We're going to have to take something away from that. What will we have to subtract from the total surface area of the big cylinder?
The base of the top.
Or what will we not paint? Think about it this way. What?
Well, 'cause 2 and then 2 on the bottom, right?
So we're not going to paint this piece right here, right?
So 2.
Because that's a hole. That's air. Or we're not going to paint this bit. Because that's also a hole. That's air.
Would they paint
Also.
inside? Or is it
Well, they're just painting the outside of the pipe, not the inside of the pipe. So, for example, if you're having trouble visualizing it, imagine that this is a cylinder instead of a prism, okay? And I have drilled a cylindrical shaped hole in it, right? So we're going to essentially find the surface area of my green cylinder here, but I'm not going to paint this part of it because if I try to paint right here, there's nothing there. It's just a blank space, yeah? So we're going to find the total surface area of the cylinder minus this circle, so minus a circle, minus another circle for the back where we have no more space. Like when I made this, I had to literally cut out a green circle to make space for my cylinder on the inside. Okay, so we are going to be in a little word thingy down here, subtracting. So we're going to be subtracting the area of the 2 circles, because there's one on the top, one on the bottom, from the total surface area of the cylinder. So we can do it separately and then we'll subtract. So first let's just find the total surface area of the cylinder. So total surface area of a cylinder, that formula is 2 pi RH plus 2 pi r squared. Good question. So if we found the lateral, then it wouldn't include like the outside of the top, like where it's in blue up there, or the outside of the bottom, which we still want to paint like some of the top of the pipe and some of the bottom of the pipe.
Okay.
Yeah.
And the radius is 2, right?
Well, what's the radius of the whole cylinder? The big cylinder? 4. So 2 times pi times 4 times 10 plus 2 times pi times 4 squared. So that's going to be the total cylinder.
Question.
Yes.
Why is the square inside the parentheses, but another equation 2 is outside?
Good question. If I had done 2 pi 4 squared or 2 pi 4 squared, it's all the same thing.
Okay.
Yeah.
So like if I put it in the calculator, it won't be different.
Right.
Okay.
Mm-hmm. I guess I just like how it looks that way.
I mean, it does look better that way.
It does look good. So I get that the total cylinder is 351.9 square inches.
Oh, I got 252.8.
Interesting.
Let me try how you had it with the fingers.
Well, that shouldn't make a difference.
Wait, it does, cause like I tried solving with the parentheses once and like it just like completely messed up my answer.
Huh? You what?
The parentheses also helps you.
Well, it shouldn't make a difference in your calculator. Did you guys get 351.9? Yeah. Okay.
You get the same answer both ways.
Yeah, parentheses or not, you should. I can come look at yours in a second if you're having issues. Sometimes calculator stuff is just tricky.
Okay, I got it now when I put the squared inside of the parentheses.
Gotcha. I can come look at yours in a second and see what happened first, though. Thanks, I'm curious.
I already completed it because my OCD deletes everything.
Oh, that's okay. That's okay. No worries.
Alright, guys.
Okay, so let's find the area then of two circles. So the circles are identical. One circle is pi r squared, and we have two of them. So I'm just going to do 2 pi r squared since we have two circles. And the radius of the circle is 2. So 2 times pi times 2 squared is the radius of the two, or the area of the two circles together. Or 25.1 inches squared. So then we'll just subtract. So I'm going to do 351.9 minus 25.1. So total I get 326.8 inches squared. Yes.
For the area of the circle, could you just do the for 1 and then times that by 2?
Totally.
Okay.
Yep. Any other questions?
Nope.